Cool. Hi, everyone. My name is Alper. I'm the Education Content Manager for this year's CodeDay Labs. I'm happy to welcome James today, and he will be teaching you guys about Blockchain 101 and Intro to Blockchain. James is a software engineer at PayPal, but if you'd like to introduce yourself a little more, James, that would be great.
Yeah. Hey, everyone. So just as a brief intro, again, I'm James. I graduated from Cornell and Georgia Tech pretty recently. And one thing that's interesting about me is that I didn't actually really start in computer science. So I actually majored in economics and found computer science a bit later. So that will lead a bit into the talk I'm giving later today as well. But at least for the time being, I work as a software engineer at PayPal. I have gotten involved in blockchain in various ways, from giving talks at blockchain conferences and expos, both in Seattle and online in various mediums. I have actually been able to get a bit involved in blockchain at PayPal as well. So I've contributed to some of the innovation work that we do in blockchain, including some stuff that is somewhat public. So if you go look up some news about PayPal and blockchain and some of the stuff that our CEO has announced, I have been involved in at least some of that. I've also previously run code days in the past and computer science fairs around the country for CodeDay. So some of you may recognize me from some of that stuff. I also gave some talks at Code Labs last year, including a blockchain talk. So I'll try to get into a bit more advanced topics this time around. Last time I kind of gave an intro of blockchain, but I'll try to go a bit deeper this time. You can also find out more about me at my website here. I believe that CodeDay is recording this, so you'll be able to go back and look up this website as well in the future if you'd like. I also have a blockchain course that I wrote, and that's on a website, so I will share that link towards the end. Just to start out, I do want to still give some intro to blockchain. I'll try to keep it to under 5 or 10 minutes to make sure that we do have time to go into more advanced topics in blockchain. But first off, real quickly, just what is a blockchain? It kind of consists of a few different things. So first and foremost, a blockchain is essentially like a linked list. So this is something where you have a first element, a second element, a third element. And in blockchain, however, the difference is you can't ever remove one of those elements. You can only ever add on to the tail end of that data structure. So with a blockchain, you have the start of your blockchain and then you add on to it over time. You can actually add those extra nodes onto that blockchain by solving hash puzzles, which is basically a small pocket of work that your computer needs to do. In something like Bitcoin, that is actually a very difficult hash puzzle. So it may take, average of 10 minutes in between each hash puzzle being solved, which may sound pretty quick until you realize that there are tens of thousands of computers working on solving those hash puzzles. So really there's a, 1 in a million chance every day per computer to solve a hash puzzle. Why would someone put their computer and their electricity costs and everything towards this? Usually, and I'll maybe get into this a bit later, for the simplest case is kind of Bitcoin. It was the original blockchain system that came out. In Bitcoin, you're actually incentivized to solve hash puzzles because you will get some Bitcoin reward in return. Right now, I think it's something like 5 Bitcoin per hash puzzle solved, which is something like $100,000 or $200,000. There are different systems where the rewards that you get for that are different. Ethereum is trying to move to fully proof of stake, which means no more hash puzzle solving. Only, if you have 10 Ethereum, then you get some kind of say in how the network operates. And the reason for that is that, if you have $1 million invested in Ethereum, you probably don't want to break the network and make your $1 million turn into $0 value. One interesting thing that blockchain actually enables is to have something called Byzantine fault tolerance. So normally in a distributed system like blockchain, You don't actually know how to trust people in your network. So the kind of rule that Bitcoin uses is, hey, if a majority of people in the network say that something happened, then it happened. And that kind of works unless you have 51% of the network saying, hey, let's give $1 million to each of us and not the other 49% of people. That's what Byzantine fault tolerance basically means. It's how resilient are you to malicious actors. So in reality, a lot of blockchain networks are around 60 or 70% fault tolerant. And there's a lot of research that has gone into how to increase that percentage upwards towards something like 80 or 90% fault tolerance, so that in order to break or cheat the system, you would need 80 or 90% control of the network, which could either be millions of dollars of computing power, or it could be millions of dollars of a given cryptocurrency. I said a lot without showing many slides, so I'll go through some of these to kind of try to illustrate some of those points. So reiterating, a blockchain basically like a linked list, except you can only ever add on blocks. One important note is that in a blockchain network, every single computer running that network will maintain a copy of the blockchain. There's some cool computer science, cryptography type stuff that can be done to make it so not everyone needs to store the full hundreds of gigabytes of the blockchain. So if you've ever heard the term Merkle Tree in relation to blockchain, that's what that is. It basically means you don't have to store everything in the blockchain. You have some kind of cryptographic proof that the history of the blockchain is represented by some smaller amount of data. This helps to make it so that if any node tries to make something up, that you know what's actually going on. So you know what truly happened, and you know that someone else in the network is lying if they add something random. This is just filling in some of the definitions here, so I already went through some of those, but you're, again, free to look back at the recording and refer to these definitions later. This is just going, again, into some of how blocks are added to a blockchain. And there are some problems with this kind of system. Again, going into Byzantine fault tolerance and the fact that some systems are only about 50% resilient, whereas others can get upwards of 70 or 80% resilient. Smart contracts are kind of another key concept in blockchain at this point. So Ethereum popped up about 6-7 years after Bitcoin came out and created this system in which you could put software onto the blockchain. What does that mean? In essence, when you have a normal software application, you tend to host it on a website, right? So you can go to google.com and it will have some kind of way to search. But you don't know what Google is doing in the background. They could have, whenever you search something, then that is not only searching something up, it's also adding to your, user data record and saying, hey, this person searched for cute dogs on the internet. And then they know that they can maybe market, dog food to you, or, various types of pet toys. And so what a smart contract is instead of being on a secret server that you don't have access to what that code is, a smart contract is saying, hey, this code is going to be stored on the blockchain, so we know it can't change. And in a lot of cases, that code is also going to be very public. So you can go look up what that code is doing. You know that it's not going to be changing. So you know that if you go and search for cute dogs on some blockchain-powered search engine made using a smart contract, that all that program is going to do is going to search up cute dogs from some database of knowledge. So this really enables a lot of stuff. I won't go too deeply into this, but hopefully if you've been interested in blockchain, you're able to look up some of the common use cases for smart contracts. One common example I tend to give is insurance. So a lot of people will kind of use insurance on the blockchain as kind of key use case for why blockchain is so impactful. So we think about the scenario where you have insurance. It's meant to cover illness, homicide, or accidents, things like that. And let's say that you have this insurance plan and you end up losing an arm. The hospital may rule it an accident, and that means that your insurance plan should cover it. However, the insurance could still end up denying it. They could end up saying, well, you had gone off track into a double black diamond while you were skiing, and that is risky behavior that we aren't going to cover. But in reality, skill level during skiing shouldn't dictate, maybe shouldn't dictate if your insurance covers something or not. So the alternative is using a smart contract where, everything is very programmatic. It's, if the hospital says, hey, this is an accidental injury, then, we're going to code it that way. And the insurance plan is going to say, if the hospital says it was an accident, then it is an accident. And if the insurance plan covers accidents, then we will pay out to the person who holds this insurance plan. And so then there's no kind of opportunity for a insurance company to come in the middle and then deny that claim. It will really end up being up to, what does the hospital decide? And because this is a smart contract, for example, that this will always be the case. There's going to be something holding that money that will pay you out based on what the hospital says. There are some kind of intricacies to this around is the hospital a reputable source of information? So maybe the hospital ends up getting bribed by an insurance company not to, rule claims in a way that they would get reimbursed. So that's fully possible. And in that way, this different kind of topic called oracles comes up. And I'll try to go a bit into that later. I believe I do not have my slides about that open. So I'll try to open that later in the call. But for now, just keep that idea in mind. Like there's this idea called oracles, and it's basically saying, how do we get some kind of data from the real world or from the internet onto the blockchain in a reliable way? Because anyone telling us that information could be lying. Especially in the case of smart contracts, you're usually dealing with some kind of money or verification process. And any reason why people might lie for any of these smart contracts, they may be incentivized to lie when reporting what actually happened in the real world. So this is just an interesting quote I found from the US Senate. Typically, if you're thinking about a contract, the judicial system will deal with disputes and enforce terms of that contract. But for a smart contract, you're not using a judicial system. You are using hard-written rules programmed into that contract using code. So again, oracles will matter here, but you get a much more strict and a much more concrete guarantee that the contract will work the way that you want. So we can say contract or program. Smart contract is maybe a bit limited because there really is so much stuff that you can do with a smart contract, a blockchain application that may go beyond the strict definition of contract or what people think of as contract. But basically, it's a smart application. It's a blockchain application that has those traits of it can't be changed and it exists on the blockchain. So it tends to be public. There are some vulnerabilities with blockchain. So there can be certain situations where a substantial portion of the cryptocurrency in a blockchain is contained within one single situation. So that could be one person owns 50, 60% of the cryptocurrency. It could be 60, 70% of the cryptocurrency could be owned by a single smart contract. All of this kind of lowers some of the guarantees that you get with blockchain. And it also kind of highlights some of the possible issues with thinking of blockchain solely as cryptocurrency. Excuse me. So even in this example where the price was down, 27%, 50%, whatever, as a result of too much of the market cap of the cryptocurrency being in a single smart contract, you actually get, the situation where nothing was actually wrong with the cryptocurrency. Nothing was wrong with the cryptocurrency. Nothing was wrong with the blockchain itself. There was no hack. There was no real issue here. But the problem was that, too much money was held up in this thing. And so by virtue of supply and demand and, availability and, just a large portion of that cryptocurrency being hacked, the price of the cryptocurrency dropped. But nothing was actually vulnerable with the actual cryptocurrency or blockchain. It was actually a vulnerability with the smart contracts that held a large portion of the cryptocurrency. I got a question around, is the IPFS a smart contract? So I think I just marked answered. So what IPFS is, and correct me if I'm wrong, it's been a while since I've worked with certain areas of blockchain, but IPFS, I believe, is a file storage system on the blockchain. So it's kind of, it is actually a smart contract to my knowledge. It's a smart contract that says, you upload a file to some kind of UI and I will stick that data on the blockchain. It may not be implemented quite that way. I would imagine it has some types of compression to make it so that you're not trying to fit 10 gigabytes on the blockchain, because that would be rather costly. But it's probably doing something like getting a hash of that data so that you can fetch that data from somewhere else, and then that those two intended bits of data are identical. So in some way or another, it's being compressed or stored off the blockchain and you're able to access it. But at its core, it's some representation of that data being stored on the blockchain so that you can always kind of access that data in a reliable way so that that data is the data that you're expecting. So I would assume that it is implemented as a smart contract, but it could alternatively, and I say it meaning any sort of file storage system on blockchain, could be implemented as its own blockchain as opposed to a specific smart contract. So there are a few different ways that kind of use case could be implemented. So in general, blockchains can offer some unique attributes, Byzantine fault tolerance, immutability, decentralization, but they may not always offer those attributes. They can't replace traditional databases unquestionably. There are scalability concerns and other types of vulnerabilities. And also using blockchain with the aspect of being immutable also means that there are some other risks associated with that. So with that being said, let's move on to the next topic I wanted to cover. I wanted to go over some of the top 10 cryptocurrencies, just to give an idea of what the market is. I actually created these slides about half a year ago, or maybe 3/4 of a year ago, so this won't be entirely up to date, but we'll give an idea of what the blockchain market is doing. And I won't say that the most interesting technology in blockchain lines up with the top cryptocurrencies, but it still does give a general idea of what are people interested in, what are they putting their money towards in the industry. Before I get into that, I'll answer another question. So someone asked, when I order something from Uber Eats and something is missing, I can go to the app and get a refund. By saying that part of the order is missing. Isn't this an example of a smart contract? I would say no. The reason why is that a smart contract is inherently something that's done in blockchain. So if you are going to get a refund from Uber Eats, that's going to be handled by some program hosted on a server built using JavaScript or Java or Python, something like that. That code lives on a server. So it lives on a computer controlled by Uber. Whereas if it were a smart contract, it would be code living on a blockchain that, thousands or tens of thousands of people have a copy of how that refund is going to be processed. So if it were a smart contract, it could be very public how your request is going through different like risk models and reliability models to figure out whether or not they want to give you a refund. And so that could take in different sources of, how often does this person ask for a refund? Does this person order here very often? And then, in a smart contract, I would expect that to look fairly simple. It might say, add all those up and say, have we still made a profit from this customer? If so, sure, we can refund them. But if you were to do that with Uber Eats, they are going to hide a lot of that from you. They may, preference giving refunds if you have a larger network. Like if more of your friends use Uber, maybe they're more likely to give you a refund. I'm not saying anything about what Uber does there, but that's the kind of thing that a food delivery company could do in order to maximize their own profits. But on a smart contract, they can't really do that because at any point you could go and look at that smart contract, see what it's doing with your request, and see if they're doing anything of that sort. And that is inherently because it would be a smart contract written on a blockchain using this kind of immutable program. So hopefully that answers it. I'm going to try to sway away too much from answering questions about the basics of blockchain and smart contracts, but I'm hoping that gives you a solid base to go off of for the rest of this call or rest of this talk. So I also just got a question about investing in cryptocurrency. I'll get into that in these slides a little bit, but I will also say, don't take any of this as a suggestion to invest. In fact, like most of the top cryptocurrencies are not what I would call good investments. Some of them may rise like crazy, but in general, the cryptocurrency markets do not really follow what I would call a technical influence. They often gravitate towards what has the best marketing and not necessarily what is the most secure. And with blockchain, if any given cryptocurrency or blockchain has like just a very simple bug, then that could mean people are able to steal all the money from that cryptocurrency. So let's say a cryptocurrency as a whole is worth like $10 billion. If there is a bug in that cryptocurrency that allows people to just wildly make new cryptocurrency without doing any work, then they may very quickly drain all the money from that cryptocurrency. And the market is not the most cognizant of those risks or of the technical advantages of different cryptocurrencies. So I would say Bitcoin and Ethereum are old enough and are big enough that, if there were those types of vulnerabilities, I think they would have been found. So I would lean towards recommending those more than anything. But just in general, it's a very volatile market. It's a very risky market. So don't invest more than you can afford to lose. If you don't know exactly what that means, I would say make sure that you can afford, rent, food, everything else first, and then even then probably limit it to like 5 or 10% of discretionary income, because otherwise you may lose much more money than anyone is comfortable with. For example, look at the Dogecoin price and what it's done. Probably not the best idea to invest in something like that. With that being said, I'll go on to going over some of the top cryptocurrencies as of 2020. In number 1 comes Bitcoin, then Ethereum, and then some other ones that you may or may not have heard of. I'll explain briefly what some of them do. I would group them in this general way. A whole bunch of them are just Bitcoin, like copies of the Bitcoin code, and so nothing is super different between them. I will go a bit into the differences between Bitcoin and Litecoin and Ripple later, towards the end of the talk. But for now, the most important thing to know is, Bitcoin, Litecoin, Bitcoin Cash, Bitcoin SV are all Bitcoin with just like 1 or 2 variables switched. So maybe instead of every 10 minutes adding a block, Litecoin might do it every 5 minutes, that kind of thing. There are also middleman tokens, which are just kind of like, there are various people, and over time this has improved a bit, but generally these are just cryptocurrencies that exist for the sole purpose of like being a sort of middleman in transactions on their product. So if you go to Binance and you want to buy Bitcoin, then you would first use your US dollars to buy Binance coin, and then with Binance coin you can use that to buy Bitcoin. Again, simplifying it a bit, but at its core, that's what these two cryptocurrencies are. There were also two cryptocurrencies invented by basically the same people. Not exactly, but basically the founding team of Ripple had some disagreements, and then one of the founders basically copied Ripple and called it Stellar. And so now there's two of them with a pretty similar system. Since they initially broke off, I think they've kind of diverged technically a bit more than when they started. But at their core, I would still group those two together. The other few top ones, as of 2020, were Ethereum, Tether, Chainlink, Tezos, and Cardano. And all of those are distinct enough that I can kind of describe what they do and why they're different, and why, blockchain and cryptocurrency is more than just this idea of the standard Bitcoin or Ethereum cryptocurrency. So again, here's the Bitcoins, here's what's different about each one. So in Bitcoin, a block every 10 minutes. First blockchain, it solved some of these initial problems, and I would definitely suggest going and reading the Bitcoin white paper. Bitcoin Cash, exact same thing, but with larger block size. So instead of adding 1 megabyte every 10 minutes to the blockchain, it adds 8 megabytes every 10 minutes to the blockchain. This has some interesting stuff, and we'll go into this later in the call as well. But this basically means it can handle more transactions per second, but it has lower decentralization because, if your internet is slow, you can't necessarily be downloading 8 megabytes every 10 minutes. As opposed to, more people are able to download 1 megabyte every 10 minutes. It's also, again, it's just a copy of Bitcoin. There's fewer people actively working to improve it than there's Bitcoin. It's also, because of it being less decentralized, it's also a bit more risky. It's more susceptible to some of that Byzantine fault tolerance kind of issues because there's a lower threshold to attack it. Litecoin is very similar to Bitcoin and Bitcoin Cash. Just instead of changing the block size, they changed the frequency of new blocks being added. And then Bitcoin SV is exactly Bitcoin Cash, except instead of making it 8 megabytes, they made it 132 megabytes. I would argue this basically means that you need a bare minimum of like 13 megabit per second internet, which really, centralizes this around Western countries and big cities, anywhere that has that good of internet. And it basically stops, half the world from being able to use it. The more interesting group, and probably where I will cut it off for these slides, are Ethereum, Tether, Chainlink, Tezos, and Cardano. Ooh, I didn't add slides for this, I guess. Did I? Yeah, okay. So let me rewind over to here to talk about each one. Ethereum, we kind of already went over. It added smart contracts. Not too much else to say there. There is some interesting stuff going on with it nowadays where they are updating some of the technology using proof of stake, as I mentioned before. Tether, on the other hand, is what's called a stablecoin. So a stablecoin is basically trying to be a linked representation of a traditionally, it's trying to be a linked representation of a traditional currency. So that is trying to say, okay, there's one Tether, and then one Tether is worth $1 US, and vice versa. So in theory, you go to Tether, you say, hey, I want to have $5 US on the blockchain. Then you give them $5 US, they give you 5 Tether, and at any point you can exchange that back for $5 US. That's a core concept behind a lot of stablecoins. Some may try to link to different currencies. Some may try to just generally keep a stable value, even if it's not necessarily linked to a fiat currency like the US dollar. I will say there are a lot of concerns with all stablecoins. There have been a lot of stablecoins in the past that have kind of instantly lost all their value for various technical or security reasons. With Tether, there's actually a lot of concern that they may not actually have the full cash value of all the Tether that they issue. So for example, there are concerns that if Tether has given out, let's say, 1 billion Tether, that there are only $1 million US in Tether's bank account. So people can, if people withdraw up to like $1 million US from the Tether system, that anything past that, they may run out of money to give back. So that's a stable coin. It's a very interesting area. I definitely like it as a technical topic because there's so much cool stuff you can do to try to solve some of those problems and some of those risks, that it isn't trustable or that it isn't going to be worth $1 when you try to get it out. But at least on the market, there are varying degrees of quality behind different stablecoins. Chainlink is super interesting because they are trying to solve various types of Oracle solutions. So again, that means something like if you were to try to say from that example before, if a hospital wanted to report, hey, this was an accident to a insurance smart contract, then how would you do that? You could have the hospital go onto the blockchain and send some kind of note saying, this person with this insurance plan had this type of visit. That being said, how do you know that the insurance company hasn't gotten access to that interface, that it's not the insurance company filling that out instead of the hospital? How do you make sure that at the hospital, it is actually a qualified person filling out that information? For example, an insurance company could bribe some kind of employee with $500 or $5,000 or $50,000 in order to avoid paying out like a $10,000 payout to the holder of that insurance plan. So there's lots of things that can go wrong with getting that sort of data onto the blockchain, and Chainlink is trying to solve some of those problems. Some types of things that they do are to, a typical example is you could try to report weather data. Do you do that by having some kind of weather sensor on the roof of a building, and then that hardware reports that data directly to the blockchain? If so, what happens if someone just moves that device indoors or moves it to a different location? Then in that way, it's not reliable. So then maybe you start creating like a wide system of these so that there's thousands of people, and if someone tries moving their device, then there's still 999 other sources of data that say, hey, that one is not telling us the right information. So that's the kind of thing that Chainlink tries to do. Tezos is actually really unique because they added on blockchain governance, which means if they're ever trying to update anything about that blockchain, then people who have cryptocurrency for that blockchain are able to vote on whether or not that change will actually happen. So if you try to make it so that anyone with 500 Tezos would suddenly have 1,500 Tezos, then people in that system get to vote on whether or not that is allowed. Whereas for some of these other systems that maybe are more centralized, where like Ripple and Stellar are more centralized, if they want to update something, they just kind of can. And it is kind of up to whoever's in that network to accept that change and use that new system. But in general, there's a lot of, I guess, influence that these centralized authorities have over more centralized blockchain systems. Whereas in Tezos, it's kind of purely, people who are already in this blockchain, what do they think should happen? Cardano is pretty similar. They are also aiming to have proof of stake. as opposed to proof of work. So if anyone with more cryptocurrency in that system will get some kind of reward, as opposed to new cryptocurrency being added by computing hash puzzles. So moving a bit onto kind of some of the differences between, some of these different metrics. So like, what does higher block frequency or higher block size cause? We can go into some of the kind of scalability differences with blockchain. So where do I start here? Here's a useful quote around kind of what's different between a lot of cryptocurrencies. One big problem in cryptocurrency, like since 2008, 2009, when Bitcoin appeared, was if you think about something like Visa or PayPal, these are systems that can handle millions of transactions per day. Some of them can even handle, millions of transactions per hour or something like that. So if you're thinking about data on that scale, one megabyte or 1 gigabyte may be taken up every few seconds. Blockchain, on the other hand, can do, 60 megabytes per hour, which would handle, not a million transactions per day. It would handle maybe a few hundred transactions per day. So in general, this quote, cryptocurrencies based on and led by Bitcoin have shown promise as infrastructure for pseudonymous online payments. So, being able to use cryptocurrency to transfer money without all of this kind of outside influences on what actually will end up happening. It can also, lower fees for transactions to make it so that remittances are cheaper. Remittances being when you send money to, dependents abroad, typically is what a remittance is. Also allowing trustless digital exchange. So, you don't have to trust PayPal or someone when you're making that transfer to actually make that transfer and not take your money. And it also allows you to have smart contracts. However, Bitcoin-derived blockchain protocols and, other types of blockchain protocols as well do have inherent scalability limits. They tend to trade off between throughput and latency. I would also add in that there are other types of trade-offs that different blockchains make. And in general, these trade-offs and these limits do withhold the capabilities of these technical systems. So first, I'll go over what are the numbers for Bitcoin. So I mentioned that in 2009, when Bitcoin started, it was 1 megabyte every 10 minutes, which results in about 3 to 7 transactions per second. 3 to 7 transactions per second might be, if you have 5 Starbucks, then they may get 3 to 7 transactions per second. Obviously, you don't want a, $100 billion system that can only support 5 Starbucks worth of transactions. So then you might think, how can we increase that? We could increase the block size, which we saw Bitcoin Cash, Bitcoin SV did. And that could increase your transactions per second by some multiplier. Multiplying it by 8 will get you up to like 50 transactions per second. Still not really enough. And suddenly you start to lose some of those guarantees around immutability, decentralization, low risk in general. So if you go even beyond that to try to get like a more feasible transaction per second, something that might start being able to support a full city worth of transactions or a full country worth of transactions, you might say, let's increase that to 2 gigabytes per 10 minutes. Suddenly, you need every node in the system, and you want it to be decentralized. So you want people to exist running this blockchain network in various countries, various cities, so that no single government or single accident or single power outage could take the system down. But then you're limited to how many computers can handle 2 gigabytes every 10 minutes. Maybe if you have fiber internet, you can handle that. Maybe if you just have high-speed internet, you can handle that. But chances are you're suddenly needing like $50 a month internet in order to participate in this blockchain. So again, this would really limit this to big institutions, big cities, people with more money and more disposable income to pay for higher internet. So probably you're not going to want to do that. You could also just make it so that you get 2 megabytes every second. That would also increase it to a more reasonable transaction per second, a more reasonable throughput. But then again, 2 megabyte per second, that's something like, again, that's something like gigabit internet. So again, not super feasible. So how do you solve this? There's some answers, but in general, you do get a trade-off here. You can either choose high throughput or you can choose latency or something there. And you don't necessarily want to force up throughput, because as you force up throughput, you get higher latency and then you get lower decentralization. Hey, this is based off of a talk I gave at PayPal. So let me skip past that a bit. You also get some solutions for increasing scalability by making the blockchain a bit less public, so that not everyone in the world can run a node, but only people that you allow in the network can actually run a node. So this would be something like you take 10 friends and you say, okay, I trust you not to try to steal all my money because maybe I know who you are and I can get that money back from you. So you may have this smaller blockchain with trusted people. And in that way, you might have the reputation of 10 of your friends to back this blockchain. It's not fully decentralized, but it's enough that it would require all of your friends to turn against you to take your $10 or something. So that works. That is a solution that is viable. It adds extra guarantee while massively decreasing risk. But still, if none of your friends, let's say you had $1 million on here instead, then that may start to convince your 9 friends to take your money from you. So in that way, there's sort of different levels of guarantees. In a public blockchain, it would take a lot of money to be able to get enough people to turn on whoever is in the system and try to take money out from that system. So there are a few different types of trade-offs. There's even one about compliance versus trustlessness. If you try to have better compliance with government regulations, then that may be something like needing to support a backdoor for security agencies to try to counter money laundering or something like that. But if you have that, then suddenly you have someone who can get more information, knows the identity of whoever in the system. So the system requires a bit more trust. It may not require trust in other people in that network, but suddenly it might require trust in the US government or something like that. There's some other things that could make things more scalable. One interesting one is called sidechains. So that's when you have like a second blockchain along your initial one. And those sidechains could be handled in a lot of different ways. You could have someone running a sidechain. It could be 10 computers in 10 different major US cities. So that sidechain is very US centric. But you could also give it a trust score. So if they're handling 1 million transactions per second and they've never been, unreliable or untrustworthy, then you may feel justified putting a $5 transaction through that system. And so you could use that for small day-to-day transactions. And what they do is every, let's say, day, they basically settle whatever has happened on their blockchain with the main blockchain. So that could be something like they handle all the transactions for Starbucks in one day. And at the end of the day, they will send out that money on the normal blockchain to whoever requires it. The systems in place to actually use sidechains in the real world today are a bit different. They end up having, let me see, I think I have an example here. Yeah, or a figure. So one big example of sidechains is the Lightning Network. They're a bit more intricate. They tend to only settle a bit rarer. So if people need their money out of the Lightning Network, then that can happen. But in general, it tries to keep more money in the Lightning Network to minimize how much interaction it needs with the actual main blockchain. Part of the reason for this is you can have lower trust guarantees around the sidechain than you do on the main blockchain. You can introduce cryptography to kind of add some extra guarantees to the sidechain. And also, it can just kind of increase the potential of the blockchain system as a whole when you're not trying to fit every transaction through this main blockchain limited to 1 megabyte every 10 minutes. Instead, you're able to push gigabytes through the sidechain and then settle, a megabyte every, 10 days or something. And that allows you to get many more transactions through the entire blockchain system. And maybe you have to have a bit more trust to use that sidechain, but you still manage to get a lot of those guarantees from the main blockchain because, of various types of cryptography. That's also one of the cool things about blockchain in general is that you can do all of these kind of cool tricks to increase some of these kind of various metrics like throughput while maintaining some of those things like, trustability, decentralization. So I'd really recommend blockchain as a general subject and as a technical interest to anyone who finds cryptography interesting, anyone who finds kind of these different trade-offs interesting. I have a few more slides I can show throughout all of this, but I do want to make sure that we end roughly on time and that I can answer some questions if anyone has them. So I will go back over to this slide so everyone can find and look at the other stuff I've written about some of these more technical subjects. So on that website, and I can probably open it up to show it as well. On this website, I've written about scalability, privacy, hackability, oracles, stablecoins, cryptocurrency exchanges, and trade-offs in pretty good detail. So if you're interested in any of the subjects I've mentioned today or dug into today, this website has a lot of the stuff I've written about these subjects, and you're free to look these up, read through it, read through some of the outside resources I've linked in this. For example, under hackability, I've linked a lot of the famous examples of when different blockchains or different cryptocurrencies have been hacked. So this is a pretty good resource on where to start if you want to learn more than just kind of the basics of smart contract and blockchain. So with that being said, do we have any questions? And you're fully free to also raise your hand and unmute your mic to ask questions if you'd like. I will give it about a minute or two, and then I will, I can talk a few more minutes about some of these other subjects, but then we'll probably be wrapping it up around 3:15. What time zone are we in? 4:15 or 4:20 Eastern time. So one person asked, what languages are cryptocurrencies written in? This is actually a really interesting question, and you can kind of find some of it. So if you look on GitHub for Bitcoin, for example, then you can actually go and find the GitHub repository of everything that happens for Bitcoin. This is a code that supports the blockchain network, so it supports computers talking to each other, computers maintaining the blockchain data. It controls how the hash puzzles are generated to be solved. It controls what reward is given for solving those hash puzzles. You can see in this one, it has 67% C++. So you're right there, a lot is in C++ or is in C. And the reason for that is that C and C++ and kind of lower lower level programming languages tend to allow the opportunity to make faster systems. That isn't a universal truth, but it is typically easier to tinker with some of the lower level stuff to optimize if you are in a lower level programming language. Whereas if you are in a higher level programming language, you might be relying on a library for something that would make it difficult to change something very low level about how the hardware operates. That being said, it's not all in C++, so you can also look up like, I think Tezos has an implementation of the network, one in one language, one in a different language. This might not be the right, oh, they use GitLab, okay. And their GitLab link is broken. But if you look up different types of cryptocurrencies, you can find that there are different implementations of the networks. So Ethereum has one version in Go, one version in, I think probably C++, and I guess it says Python is used a lot here too. So you can kind of see that you can kind of make blockchains in any language, but people do kind of gravitate towards lower level programming languages like C or C++. What are some of the skills and personal projects that employers are looking for in the field of crypto as a software engineer? That's a good question as well. I would say it spans a lot of different skills. One skill that is very in demand is being able to use smart contract programming languages. So for Ethereum, there's this language called Solidity, and you can actually see the Solidity programming language code base right here. And so smart contract development and blockchain programming languages basically are a bit different from normal programming languages because they have to interact with this like unique data structure called the blockchain. So typically you have some intricacies like every transaction needs to be paid for in some way. So you are paying like 5 cents of that cryptocurrency to call a function in that smart contract programming language. So there's some intricacies there like that. There's a lot of concern about like best practices, so making code that is not susceptible to being hacked, making code that isn't going to lock up money in a way that no one can withdraw any of the money from that smart contract. But in general, that's one of the big ones that's desired. But if you think about a company, and a lot of blockchain companies like PayPal or like a typical cryptocurrency exchange, actually have to make like typical front-end websites. They need to have back-end infrastructure that isn't blockchain related. So you can kind of be any type of engineer and still be able to join the crypto field as a software engineer. But there's kind of a difference there between, do you want to work in smart contract development or do you just want to work in the crypto space in general or the blockchain space in general? The caveat I would put there is if you are going to be helping to build a blockchain, that is a different question. That will require a different set of skills. You can start by reading some of the Bitcoin white paper, the Ethereum white paper, and those papers talk a bit about, what you need to do to make a blockchain. And then that can give you a better idea of what would be required to make a blockchain as a software engineer. Another question is if governments are trying to push against crypto, but blockchain is becoming more common for the private sector, the economy, businesses, how will this influence the future of cryptocurrency? This is kind of a very common question in the cryptocurrency and blockchain space. I will say that certain governments are more amenable to it than others. Obviously, in the US, there is a lot of concern about anti-money laundering and making sure that money is not being used to fund any illegal activity. And so there's a lot of regulation in the US that kind of supersedes some of the original goals or guarantees of cryptocurrency. So while you still may be able to get something like low transaction fees, if you're trying to buy cryptocurrency in the US, you are generally going to need to get your identity verified. That will basically link your identity for whatever government gets that information to whatever wallet address you have, whichever ones you interact with. So generally, that's kind of already happening. There are a lot of governments that are happy just to know what you're doing in cryptocurrency through that kind of identity verification process. There are some that try or have tried or are trying to fully ban cryptocurrency, which is a bit more difficult. And then there's some that kind of fully embrace it and maybe even carve out some exceptions for it in financial, regulations. I would say, adoption is rising so quickly, and a lot of governments are kind of getting more amenable to it over time because of the industry that's grown up around it, that I wouldn't worry too much about the future of cryptocurrency. And any impact is probably likely to be short term or localized to certain geographies. But if the past, decade and a bit have shown us anything about cryptocurrency and blockchain, it's a very complicated system and a complicated industry where there's new solutions popping up every time, whether that's to be more private from governments or, more secure for governments and for users. And so the real question there is, what do you want with your cryptocurrency or with your blockchain? Do you want the full privacy, even against the government, or do you want to be compliant? And I don't invest too much in cryptocurrency or blockchain, but I would say, that question is kind of up to the individual. And I think the only way to really know if a given cryptocurrency or blockchain fits what you want from that use case is going to be if you learn about the technology. And I think that's also where a lot of investors in cryptocurrency go wrong, because a lot of people investing in it are not technical. A lot of them can't read a white paper and understand, hey, there's some vulnerabilities here. Hey, this thing relies on an oracle, and if that oracle system is not secure, then maybe this entire use case is, for nothing. Maybe there's some great vulnerability here that could lose all the money. So I wouldn't say I know for sure what's going to happen, but I do expect blockchain and cryptocurrency to stick around. It's just, which guarantees do you maintain? Which ones do you lose? What benefits or detriments do you get from it? And I think one major benefit that we can get from blockchain and cryptocurrency is a pressure in the general financial sector to lower fees for all types of financial transactions. We're running a bit out of time, but I'll try to answer some of these very quickly. One is, what threats do I see in the future of further adoption of technologies based on blockchain? Short answer, scam coins. Like, I think there's so much money going into blockchain and cryptocurrency that it's just really hard to, continue something if there's billions of dollars being scammed from, people who just aren't knowledgeable enough to know better. That will fuel increased regulation and slow down adoption. To follow up with my previous question, do you think quantum computing could pose a threat? Quantum computing can definitely pose a threat, but if it's going to pose a threat to blockchain, it's going to pose a threat to everything. Just about every system nowadays centers around a few different types of encryption. And if quantum computing comes around, then basically no system is safe. So any system that you have that requires a password is going to be able to be hacked with quantum computing, in theory. And so I just think, it's not worth worrying too much about blockchain in that scenario because just everything is at risk. So it's not like leaning more heavily towards traditional systems is going to be better if quantum computing comes around. And then last two questions. May noted that C++ was faster than some other stuff. Yeah, that's generally true. It's just lower level and it uses less code to accomplish the same results, but it does make it a bit more complicated to actually write code in those languages. The other comment from me was, I noticed that I did not mention Dogecoin. I actually mentioned Dogecoin very briefly. It did start as a meme. I know a limited amount about it. I think it was just a clone of some other cryptocurrency. I don't remember which one. It was just a clone of some other cryptocurrency with a silly name around, Doge as a meme. So it getting as much value as it did, in the past few months was just kind of absurd. They also mint a lot new cryptocurrency very rapidly. So like there's going to be massive like inflation in it just kind of by default. So it was just kind of a bad long-term investment since it came around. So all the power, I guess, to anyone who made money on it, but I was pretty disgusted throughout the rise of Dogecoin's price about how many companies were marketing around Dogecoin and just saying things like Dogecoin up 500%, invest all your money. And, I could just foresee, this price is going to crash pretty soon. And then all the people who just didn't know better about investing in it are going to lose thousands of dollars. So I'm pretty disappointed in a lot of the companies that were marketing Dogecoin that way. And I, won't go too much into business ethics, but I think it was a bad choice by some of the cryptocurrency exchanges to be framing any marketing that they had around Dogecoin's price increase. And their last comment is just thanks for the talk. And to that, I'll say thank you everyone for attending. I hope it helped, and definitely feel free to check out some of the other resources I shared around this website, around this, all the stuff I wrote, or to check out my personal website, and hope that everyone knows a bit more about blockchain and cryptocurrency now.
Thank you so much, James, for spending all this time with us and teaching us about blockchain. It was very informative.
Yeah, it was a lot of fun.
Thank you. I hope everyone has a great day, and James will be having another talk in about an hour about why to be a software engineer, why to go into that career path. So if you guys are interested in that, please make sure to attend. I'll see you then. I'll see you then, James.
Yeah.
Bye,
See
everyone.
y'all.
Bye.